In this video, I'm going to demonstrate writing a class using the test-driven development methodology. The class I'm going to write will model the marks for a student over 12 weeks of labs, and those lab tasks will be marked out of 5 each, and a student's overall mark for the lab tasks will be their best 8 marks for those labs, out of the labs that they do have marks for. That's the class I'm going to write. But in this video, I'll be using the test-driven development methodology, which is a way of writing software. In the test-driven development methodology, or TDD, we write software in short cycles of writing a test and then writing the behavior that makes that test pass, and then we keep cycling through until we've written all of the behavior that we need. Because we're writing the tests first, I'm going to start by creating a test class, and you'll notice here that I'm using IntelliJ IDEA, which is an IDE for developing Java applications, rather than BlueJ. I'm using IntelliJ IDEA here rather than BlueJ because IntelliJ has a lot more features that make it easier for me to develop software, especially if I'm using the TDD methodology. I'm going to start by creating a test class, and this class will contain the unit tests for the class I'm going to write. So I'm going to call this LabMarks test. So to start off with, I have this empty test class, and I'm going to import the JUnit library so that I can use that. So I need to use the test class from JUnit, and that means I'm going to need to add JUnit4 to the class path. We're also going to use the assert methods. And this should be a static import. So inside this test class, I'm going to be writing my unit tests. This test class is going to test a class named LabMarks. So to start off with, I'm going to create a LabMarks field. And already I can see that there are errors in this code because the class LabMarks does not exist. We haven't created this yet. So I'm going to start by creating another class called LabMarks. And now that I have this class named LabMarks, this error will go away because the class does exist, and I can create a LabMarks object. What I'm going to do is split this vertically so that I can have my test class on the right-hand side and my implementation class on the left. So from here we can continue developing this class using the TDD methodology, and I'm going to start by writing a unit test. The LabMarks must belong to a student, so I'm going to check that the LabMarks class has a student ID and that I can get the student ID. So to start off with, I'm going to give this LabMarks object a student ID in the constructor, and let's say that the ID is S1234567 and I'm going to write a unit test. This should be public void test student ID, and I'm going to assert that when I get the student ID, it is equal to 1234567 with an S at the start. So I'm going to say marks.getStudentID. And here I have a test that's not going to compile. You can see there are 2 errors here. The first is that I need a constructor that takes a string, and there's no method getStudentID. So now I'm going to move to the implementation class and make this test pass. To start off with, I need a constructor. And this constructor is going to take a student ID as a string. And then I need a getStudentID method, and this is going to be a string. And at the moment this class here doesn't compile, but now we can see that the test class does compile. And we're just going to write enough code to make this compile for now, so I'm going to say return null. And I want to see that when I run this test, I should see a test failure, because I'm not going to get S1234567 from the getStudentID method. I am actually going to get null because that's what it returns. So when I write a unit test, I want to check that that test fails before I write the code to make it pass. So now let's make this test pass. To do this, we're going to need a field called student ID, and that means we're going to need to declare this field, and we're going to have to assign it in the constructor. And now that I've written the code to make this test pass, I'm going to run the test again. And now I see that that test passes, so I can move on to writing the next test. The next test will be that I want to be able to set a mark for a week. So I'm going to write another unit test. And we're going to test that if I set a mark in week 1, then I should be able to get the mark in week 1. So I'm going to say marks.set mark for week 1, and we're going to set this mark to, let's say, 3.5. So that's 3.5 marks out of 5. And then we're going to assert that when I call the getMarks, or the getMark method, I'm going to get 3.5. And I'm going to call the getMark method with week 1. So here I'm specifying that I'm going to call a setMark method to set the mark of 3.5 in week 1. And then when I call the getMark asking for the mark of week 1, I'm expecting a result of 3.5. Now this isn't going to compile, so I'm going to need to write these two methods, at least stubs for them. So I'm going to say public void setMark, because this setMark method, it doesn't need to return anything. And this setMark method does need to take these two parameters. One is the week number, and the other is the actual mark. And that mark is going to be a double, because I can see that I've got a 3.5 out of 5 as the mark. So I'm going to write to do here to say we haven't written this method yet. We also need a getMark method, so I'm going to write that as well. This getMark method is going to return a double because I'm expecting it to return 3.5. So the signature here should say the return type is double. The name of this method is going to be getMark, and I need to say which week I want the mark for. And at the moment this method is not implemented, so I'm just going to make it compile. I'm going to return some default value of 0.0 here. That's a double. So now the test class compiles, and I'm going to run this test and check that it fails. So firstly, we can see that there's an error here because I'm using assert equals to compare doubles. When I do this, I need to specify an error tolerance for the equals check. In this case, I want the number 3.5 to be exact. There is no error tolerance here. But to make JUnit's assert equals method work, I'm going to specify an error tolerance of exactly 0. I'm going to write 0.0 here. That's the same as writing 0, but if I write 0.0, then it's obvious that that's a double. And now when I run this method, it should fail because I haven't implemented the getMark method. So the getMark method should return this 3.5 because that's the mark I set, but it's actually returning 0 because that's what we've written in the getMark method here. Now that I've written a unit test and we've checked that it fails, we're going to implement the behavior to make this unit test pass. So firstly, I need somewhere to store the mark that we're setting. And then I need to put the mark into that storage place, and then I need to be able to retrieve the mark from that storage place. And we want to be able to set the mark for a week number from 1 to 12. And what I'm going to do is declare an array to hold these marks. So this marks array will hold doubles. So it's an array of doubles, and we're going to call this array marks. And we're going to create an array when we create the student, or we create the LabMarks object for the student. So we're going to say this.marks equals new array of doubles, and because there are 12 weeks, I'm going to create an array with 12 components. At this point, we need to be able to put something into the array and get something out of the array. So the simplest thing for me to do here is to use the week as the index in the array, and then put the mark in the array at that index. So I'm going to say this.marks for that week equals the mark. And then to get the mark, I'm just going to retrieve this.marks for the week. So now that I believe I've written enough code for this test to pass, I'm going to run the test again. And this test now passes. If I run all of the tests, then I can check that my test student ID test still passes as well. So now that my test passes, I'm going to move on to write another test. I can expect that there's an error here, or there's a problem at least, because we want the weeks to be numbered from 1 to 12, but I've used the week as the index in this array. And we know that arrays are indexed from 0, not from 1. So the first index in this array should be from 0 rather than week 1. That's going to be a problem when I try to set a mark for week 12, because 12 will be out of bounds for this array. So I'm going to write a test to make sure that 12 is in bounds when we call the setMark method. So I'm going to call this test week 12, because that's the behavior I'm testing. I'm testing that the setting marks works for week 12. Or maybe I should call it test set mark week 12. So I'm going to call marks.setMark for week 12, and I'm going to set a mark of, let's say, 4.5 for this week. And then I'm going to assert that I get a mark of 4.5 when I call marks.getMark for week 12, and there's an error tolerance of 0 here. I want exactly 4.5, because that's the number I put in. So I'm going to check that when I run this test, it should fail. We can see that this test fails because I have an array index out of bounds exception. 12 is not a valid index in this array. The last index in the array is 11, because the length of the array is 12. So to fix this, all I need to do is make sure I'm using a valid index in the array. And to adjust that, I'm going to turn the index 1 into an index 0 and the index 12 into an index 11. To do that, all I need to do is subtract 1 from the week when I'm accessing it in the array. And that's in both cases where I'm accessing it. Now I believe I've written enough code for this test to pass, so I'm going to run my tests again. And now I can see that the test setMark week 12 method, this test passes. So now that we've implemented the behavior to make that mark pass, we're going to write another test. I want to be able to test whether a mark has been set in a particular week. So I'm going to write a test method here to say public void test hasMark. And the reason for this test is I want to test that there's a method that will tell me if this student has a mark for a particular week. So firstly, I'm going to assert that I don't have a mark, so I'm going to assert false, and I'm going to say marks.hasMark for week 1. So if I haven't set a mark for week 1 yet, then there shouldn't be a mark, so I should get false from marks.hasMark. In order to make this test compile, I'm going to need to write the hasMark method, and we know that this method must return a boolean and it must have an int as its parameter. So I'm going to write public boolean hasMark, and then the parameter will be the week. So this test will now compile, but the LabMarks class doesn't compile, so I'm just going to write a stub class here. So I'm going to say return false. I'm going to write a stub method for the hasMark method. And we'll fix this later, but for now I want to make sure that this test fails so that I have something to write. So I'm going to run this. And actually this test passes because the stub method returns false. So I haven't written enough of a test for this test to fail yet. This test doesn't really properly test the behavior of the class because it passes erroneously for a stub method. So what I'm going to do is call the setMark method in week 1 and set a mark of 3.5 and then assert that after I've set the mark, I should get a true when I ask is there a mark in week 1. I've set a mark in week 1, so now when I call hasMark, I should get true for week 1. And now I'm going to run this test again, make sure that it fails. So this test does fail. And now we need to write enough code for this test to pass. So the simplest thing for me to do here would be to check if the mark is 0 or not, because this array of doubles will be full of zeros when I create it. And if I've set a mark, then if that mark is more than 0, then it won't be 0. So I could test if the mark for that week is 0 or not. So I can use this .marks week -1, and if that's equal to 0, then there is no mark. Or if it's greater than 0, then there is a mark. So now let's run this. And I expect this mark to pass, this test to pass. So this test does pass. But we can already imagine that there's a problem here, because if a student does actually have a mark of 0, then this hasMark method is going to return false. So I'm going to write another test to test for that problem. So we're going to test has a mark of 0. I'll call this mark of 0, spell it out in letters. So what we're going to do is say marks.setMark. We're going to set a mark in week 1 of 0, and then we're going to assert true that there is a mark in week 1, because we've set a mark in week 1 of 0. And now when I run this test, I'm expecting it to fail, because the behavior of my hasMark method is that it only thinks a mark above 0 is enough for there to be a mark. So now that I've got a failing unit test, it's time for me to move back to my implementation class and write some more code. The correct thing for me to check here is that it has a mark if it's greater than or equal to 0, because 0 is a valid thing for me to... it's a valid mark for to be in this array. So this should now make the test has mark of 0 pass. So when I run this, I can see that it does pass, but there's obviously a problem, because if I run all of the tests, we can see that there's a regression error. The hasMark test is failing because we said that there should be a false from hasMark before I've set a mark. And the reason this is failing is because this double array contains lots of zeros. It's full of zeros to start off with. But we said that if it's at least 0, then there is a mark. So the mark has been set. So therefore this setMark method doesn't need to be called for it to be at least 0. And that's why we're getting a failing test hasMark test. To fix this, what we need to do is make sure that this will be false if a mark hasn't been set. And to do this, the simplest thing I could do is just fill this array of doubles with some negative numbers. So I'm going to say that a -1 means there is no mark for that week. And to do this, I'm going to use the arrays.fill method with marks and -1. This means I'm going to need to import the helper class java.util.arrays. So if I fill this array with -1s, then a negative number means it hasn't been set. Anything above 0 means it has been set, or 0 also must have been set if it was -1 before it was set. So now we're going to run all of our tests again and make sure that we've fixed that bug. So now all of these tests pass. I believe that I've solved that problem. Okay, so the next thing I want to be able to do is to get the total marks. So I'm going to write a unit test first. So if I set several marks, then when I get the total, I want the total of those marks. So I'm going to set a mark in week 1 of, let's say, 2. I'm going to set a mark in week 2 of, let's say, 3.5. And I'm going to set a mark in week 3 of 1. And when I get the total of these, I'm expecting it to be 6.5. So I'm going to assert equals that I get 6.5 when I call marks.getTotal. Now this will fail because I don't have a getTotal method, so this won't even compile. So now let's write at least a stub method to get the total. We know that this method takes no parameters because I've given it no parameters here, and it should return a double. And to start off with, I'm just going to write a stub method that returns 0 so that this class compiles and I can run the test. And again, we've got this problem here, which is that I need to give it an error tolerance here. So I'm allowing an error tolerance of 0 when I do this test. So now let's run the test and make sure that it fails. So I do get a failing test. I expected 6.5, but I actually get 0 because the stub method returns 0. Now I'm going to move back to my implementation and try to make this work. So to make this work, I'm going to need a variable that holds my total. And this total is going to start at 0. And we're going to return the total from the method. But to calculate this total, we're going to need to loop over the elements of the array. So I'm going to write a loop. So for each mark in the array, and the mark is a double, we're going to add the mark to the total, but only if the mark is set. So if the mark is -1, then I don't want to include it in the total. So we're going to say if the mark is greater than or equal to 0, then it has been set. In that case, I'm going to add it to my total. And at this point, I can run my test, because I think I've written enough code for it to pass. and now I can see that the test does pass. Let's run all of my tests to make sure I have no other failing tests. So this is okay. The next thing I want to do is make sure that it's only adding the top 8 marks that have been set. So to start off with, I'm going to write a test where I set all 12 marks, and I expect only to get 8 of them added up. So I'm going to call this test total of 8 marks, and we're going to set all 12 of these marks. So to do this, I'm going to write a loop. Let's say in week equals 1, while week is less than or equal to 12, we're going to increase the week by 1. And for each of these weeks, we're going to set the mark for that week, let's just say to 2.5 for now. And then we're going to assert that the expected mark here, well, I want it to be the total of 8 weeks times 2.5. So 8 times 2.5 should be 20. So I'm going to assert that I get 20 when I call marks.getTotal. This should be the getTotal method. And I need an error tolerance here, so I'm going to set 0.0. When I'm dealing with halves or quarters or something like that that fits into a binary system, then I can get exact results with doubles, so I'm allowing no error tolerance here. Let's run this test to make sure that it fails. So we can see that this does fail. I expected a total of 20, but I actually got a total of 30. And the reason for this is that we're just adding all of the marks from the array rather than just the top 8 marks. So what I'm going to do is change this method so that it just adds 8 of those marks. So we're going to count how many marks we've added. And that's going to start at 0. Each time I add a mark, I'm going to increase the counter by 1. And we're only going to add a mark if the counter is less than 8. So that's what I'm going to do to change this method. So now let's run all of my tests again and make sure that they pass. So this now passes. All I needed to do to make this test pass was to make sure I was only adding 8 marks or less. We can see that this still passes. The total mark when I've got 3 weeks set is still 6.5, so I haven't introduced any regression errors with this change that I've made. Now there's a problem here, which is that we're just adding the first 8 marks that are set, and we want the best 8 marks to be counted, not just the first 8 marks. So I'm going to write a unit test to make sure that we're adding the best 8 marks rather than just the first 8 marks. And I'm going to call this test total of best 8 marks, because that's the behavior I want to test. In this case, I need to set some low marks at the start and then some high marks at the end that will be missed. So I'm going to write a loop to set the marks in the first 8 weeks to be 1. So in these first weeks, we're just going to set a mark of 1. And then for the next 4 weeks, that's weeks 9 to 12, we're going to set a mark of 2. And then we're going to assert that the 2s are counted. So the expected total here is 4 2s and 4 1s, which should make a total of 8 plus 4 is 12. So I'm expecting a total of 12 here, and this should be what I get when I call the getTotal method. And again, I have no error tolerance here. I'm going to put an error tolerance of 0 for this test. Let's make sure that this test fails. So I have really identified something more that I need to write. So I do get an assertion error here. We get an actual total of 8 because it's just adding the first 8 1s rather than the best 8 marks. So we do need to fix the getTotal method. Let's move back to our implementation code. What we need to do is to get the marks that are set and then find the best 8 of them So one way to do that would be if we sorted the marks. Now I don't want to sort this array here, because if we sort the array, then it could mess up which marks are set in which weeks. So if I set a mark in week 1 and then we sort it, that mark will be set for a different week. I don't want that to happen. So what I'm going to do is create a list to hold these marks. And this list will hold marks. Those marks are doubles, so this must be a list of doubles. And these are the marks set. And we're going to create a new array list object here to hold the marks that are set. To fix this, I need to import list and array list. So let's import java.util.list and array list. So now this code compiles. I'm not doing anything with this list yet, though. So the first thing I'm going to do is remove this counter, because we want to add all of the marks that are set to the marks set list. And now I don't want to add it to the total anymore. I just want to put it into this list. Now that I've got the marks that are set in a list, I'm going to sort the list. So I'm going to use the collections.sort marks set list. And this means I need to import java.util.collections. So now I've sorted the list, and now I want the top 8 marks from this list. So let's write a loop to get the top 8 marks. Well, we don't know the length of this list yet, so if the length is less than 8, then we just want all of them, or if the length is exactly 8, then we want all of them as well, and if the length is more than 8, then we want to get rid of the ones at the start of this list. So what I need to do is I need to know the index at the start here. So I'm going to need this index at the start, and I'm going to say int I equals index start, and then while I is less than the size of the list, I++. And this index start is going to be 0 if the length of the list is 8 or less, and it's going to be the length minus 8 if the length is greater than 8. So if the marks set dot size is greater than 8, then we're going to update index start to be the size minus 8. And that will ensure we're starting 8 away from the end of the list, so we get exactly 8 of them in that case. If there is a mistake here, then we'll catch it when we run the tests. And now when I start at this index start, I'm going to go all the way to the end of the list, and what we want to do is add that mark to the total. So we're going to call the markset.get at index I. And now I believe I've written enough code for this test to pass, so I'm going to run all of my tests again. And those tests all pass, so it seems like I've made this class work. So this is as much as I'm going to write for this class. I've decided what I wanted these methods to do. I decided what I wanted the behavior of them to be in several different circumstances. And then the way I wrote the class was using the TDD methodology, that's test-driven development. So before I wrote any code in the LabMarks class, I started by writing a unit test in the LabMarks test class, and I wrote one unit test and then wrote just enough code for that test to pass. And then I wrote another unit test and just enough code for that test to pass. And if at any point one of my old tests started failing, then I needed to go back and fix that bug. But otherwise, we're just continuing in these cycles of write a bit of test, write a bit of code, then write a bit of test, write a bit of code. And at every point, I'm expecting to only have the most recent test failing. If any of my older tests fail, then I need to go back and fix a bug. But all the way through this, I generally have all of my tests passing except possibly the most recent test that I've written. Now that I've written all of the methods I want, then there are no more tests to write, and there are no more tests to make pass by writing more implementation. So we're going to end this video here.